Is there a lot of background noise? Can someone confirm that?
Yeah, there is. There
is. Okay. My brother and kids came alone, so unexpected visit.
No problem, sir.
Yes, give me a second.
Morning it was there, but it was very distant.
That was my son alone. Now
Okay.
he has his cousin as well. So
Okay.
you can imagine the.
Correct.
Just switch on the headphones. Let me try this.
Is it better now, or you're still able to hear a lot of noise? If it goes beyond a particular threshold, let me know. Okay, I'll ask them to move to some other room. It's just that they got really excited when they saw each other after some time.
I think it's manageable. If it crosses, we'll tell you, sir.
Yeah, please, please. Thank you so much. Okay, so we'll get started. I'm just starting on time because we are kind of, as I told, a bit. We have a bit of issue with the time, so we'll get started. So what we were discussing was the ER model for UPS. Now, moving on, we also learned about what relational model is. Relational model is nothing but you have a table. Relational model transpires to or converts to a table in your DBMS, and then tuple is nothing but a row. We already saw this. I'm just trying to brush it again. When we try to implement it into DBMS, so that you can have the connections made. Okay, so relation is nothing but a table. Here the relation name is book. Again, the table name also would come as book. Tuple is nothing but a row. It is also called as a record. A row in the relation is a tuple. So when it comes to your book table, you call the rows, and when it is in your relational model, you call it as a tuple. And the same concept you use in Python as well, right? You remember when you have a set of values together, you call it as a tuple. The next one is attribute. Attribute is nothing but the columns. Okay, a column in the relation or in table you call it as fields as well. Attribute. Okay, a column in the relation it's also called as a field. Now, next one is the domain of attribute. I'm just giving out terms that are relevant to the relation model. So first one is relation, next is tuple, then you have attribute. Domain of an attribute is nothing but the set of values that an attribute can take. My favorite example, the phone number. Okay, if you have a phone number as a field or an attribute in your relational model, what does the domain of attribute say? It says that the number has to be, phone number has to be a 10-digit number. It has to have only digits. It cannot have any other characters. Okay, that is what domain of an attribute means. Now, there are certain concepts which is constraints and key. Most of them who has worked on DBs would be knowing this, who has worked on RDBMS would know it, but just to kind of refresh it, domain constraints is, there are two types of constraints. The first one is the domain constraint and the other one is the key constraint. What is domain constraint? Domain constraint means that an attribute can take values only from its domain. An attribute can take values only from its domain. Now, again, I always use the same example, phone number. Now, it also means that, I mean, it doesn't, in certain cases where you don't have phone numbers, it is also permissible to put null values. Okay, so certain cases where even if you mention the domain constraint that a phone number should only have 10 digits, there can be situations where you don't even have a phone number. In such cases, null is also permissible. That's what this means. The next one is the attribute values should be atomic. It should not be composite or multi-value. Meaning, when you are designing a relational model, a table out of a relational model, the attributes or the columns should be atomic. It should not be composite. Meaning, if you are trying to put in a field like full name, that is a wrong design. You have to split it as first name and last name, keep it as two attributes. Your attribute should be atomic and not composite or multi-valued. You can't have commas in between and say that, hey, I have two phone numbers, so first phone number is this, comma, second phone number. No, you will have to come up with an idea, maybe put it as two records or some other way. You can't have it have multi-value or composite attributes. Now then comes the key constraints. The first one is no duplicates should exist in a relation. Okay, there shouldn't be exactly duplicate rows in your relation. Exactly duplicate rows means all the fields of two records have the same value. That shouldn't be there in your relation model. How do you implement this? It's using your primary key. Now, before that, let's understand what super key, candidate key, primary key, and foreign key are. It's very easy to connect all this, but you should be a bit careful when you understand it. That's all. Super key is a set of attributes that helps you to uniquely identify each record. So, super key is a set of attributes, means it can contain one or more columns of the table, and using that set of columns, you can uniquely identify a record. That is what super key is. Now, candidate key is that key which has minimum number of attributes to identify a record. So, for example, let me just shoot up my Excel to show an example. So, let's say that I have a student table where you have student name, student ID, department. I'm just giving an example, okay, here. So let's put the name of Vijesh, student ID 1, department TSC. Okay. Now, what is super key? Super key helps you to uniquely identify a record. Vijesh, student ID 2, department ECE. So, a combination of student name and student ID helps you to uniquely identify a record. Correct? A combination of student ID alone uniquely identifies a record. A combination of student name, student ID, department helps you to uniquely identify a record. But a combination of department, student name will not help you to uniquely identify a record. Correct? So the super keys here are a combination of student name and student ID, student ID, student name, student ID and department name, all these three, and then student ID and department. Correct? So student name and student ID can help you to identify a unique record. Student ID can identify your unique record. The combination of student name, student ID can, and all these are called as super keys. This is one super key, this is another super key, this is another super key, and this is another super key. A combination or a set of attributes which helps you to uniquely identify a record in a table is called as a super key. Okay. Now, what is candidate key? Among these super keys, the key which has the minimum number of attributes in it is your candidate key. It acts as a candidate for the primary key. That is why it is called as candidate key. All these are super keys. They are super. They will let you identify your record uniquely. Hence, they are super. But out of them, one acts as the candidate to become the primary key. Which one? The one which has the lesser number of attributes in it. Let me add one more key here. roll number 90087CS, B09091EC, B090001 EC. Now again, one more key got added now. So your super key has roll number as well. Again, this roll number gets added to all this. Why I added this roll number is, in addition to your student ID, roll number also can be used to uniquely identify a record, which means your super keys are this and your candidate keys are this, which means that any one of this can, both of these keys are candidates to become a super key. Okay, that is what candidate key is. How do you know which is a candidate key? You look into the super keys, you find out the ones which has the minimum number of attributes. What is super key? You look into your table, you select all those attributes, all those combination of attributes which helps you to uniquely identify a record. Now, what is the primary key? Primary key is that key which you or the DB admin chooses out of the candidate key to make as the primary key. It can be either student ID or roll number. Anyone can be chosen. It's up to you. So let's say you choose student ID. Then your primary key is student ID, etc. etc. I can also make roll number as the. So super keys, from there you select the candidate key, from there you select the primary. Now, if in scenario, that most of the cases, you won't be having two super keys with more than one attribute. I mean, with minimum number of attributes. Usually it will be like this. And so it will be an obvious choice that your primary key is student ID. All good with this? Super key helps you to uniquely identify all the attributes, all the different set of attributes that help you to identify the record uniquely. From there, you find out the ones which has the minimum number of attributes. Those becomes your candidate keys for primary key. Among them, you choose whichever you want based on your business logic or based on your intuition or based on your educated ideas, you do that. Stop sharing. Let me go back to PPT. Okay. Now, this is what your super key. I hope you are seeing my my PPT right now. You are seeing. We saw what is. Yeah, you saw what is super key. You saw what is candidate key. You saw what is primary key. Now, the next one is foreign key. Foreign key is that key which helps you to connect to the primary key of another table. Say, let's take the example of employee and department. Okay, your employee table will have employee ID, employee name, department ID, etc. Your department table has department ID and department name. So the department ID of the employee table is a foreign key which references to the primary key of the department table. All good? I think this is very, very familiar thing to you, right? Now, there is one more key which is called as the alternate key. Alternate key is nothing but all those keys, alternate key is nothing but all those keys other than the primary key. So here, for example, when we had roll number also, you chose student ID as your primary key. If you choose student ID as your primary key, your alternate key is roll number.
I think your screen is not shared.
Sorry, Microsoft Teams doesn't allow me to share two apps at a time.
Yeah, this is happening.
Sorry, I hope you are seeing right now. Okay, so the earlier scenario where you had roll number as well, which was a candidate key, if you choose primary key to be student ID, then your alternate key is roll number. If you choose roll number to be as your primary key, your alternate key is student ID. So the keys that are left behind in the set of candidate keys after choosing your primary key are called as alternate key. Clear? So super key, all the combination, candidate key, minimum attributes, who becomes candidate for the primary key, whichever gets chosen as the primary key becomes the primary key, the others would become the alternate key. Great. Now let me move on. Let me share the PPT. Okay.
What was the foreign key if an attribute can only take one attributed value which are present as value, some other attributes? An
No,
attribute.
so you're asking me what a foreign key is?
Yes, once again, if you can.
Yes, sure. No issues. We'll do that. So employee ID, employee name, and you say that you have department name and what else? Department name, department head, department office.
Again, Excel is not shared.
Oh, I'm sorry. Please, really sorry. I keep forgetting.
So you can share the desktop so that wherever you alternate, we can see that.
Yeah, that is a good idea, but I have certain things which I don't want you guys to see.
Okay, no problem.
Employee ID, Mary, department name of, let's say, customer experience, department head of, let's put Digish, department office location is Bangalore, and employee ID 2, let's say I have Rohit, CX, Digish, Bangalore. Then 3, you have Rahul, CX, Viji. You see what is happening now, right? There is a 4. Let's say you have Rahul again, but he belongs to sales under the manager Rajesh, and his location is Hyderabad. You see that the data, this thing is getting repeated, correct? It's redundancy. Why do you have to repeat it again? This is where the normalization and all comes into picture. Basic idea is you try to avoid the repetition of data. How do you do it? You create a new table. Okay, you create a new table, remove all the redundant data, and you add an ID to it. You say that department ID belongs to CX, department ID 2 belongs to sales. Now what you will do, you will bring this department ID here, add 1, 1, 1 and 2 here. Understood? So that you are not repeating a set of attributes again, thereby you are not you are trying to save the space and performance, etc. And this is what is called as normalization. There are many levels to it. It is covered under data warehousing. It's out of our purview right now. But again, which is the primary key here? Your department ID, right? This department ID can uniquely identify a record here. Am I right? So this is the primary key here. Now, this primary key, when it comes to your employee table, it becomes the foreign key. So foreign key is a key in your table which connects to another table where that particular key is the primary key. So your department ID in your employee table is a foreign key which references the primary key of department. Understood? Confusion?
Yes.
No. Okay, great. So again, before I forget, let me share. Cool. With constraints and keys. Now, how do you convert your UR model, a simple case to relational model? You have an attribute, you have an entity, you have the attributes, The entity becomes your table and the attributes becomes your columns. That is how you convert an ER model to relational model. Now there are many things to be added. We will see as we go. Another example. That's all. Now, when you convert an ER model to relational model, so the first thing that we did is we build out a table for each of the attribute, right? There is an attribute book, you build a table out of it. There is an attribute to author, attribute author, you build another table out of it. Now, this book and author would has a relation, right? How will you show that in your relation model? And this is how it is. So this is your author table. Your primary key is author ID. You have all the attributes. This is your table. It is related to author list. What is the relationship? 0 to many. An author can, an author may be present in this author's list. He might have multiple books written or 0 books written. A book might be authored by an author, multiple authors. A book might exist without an author or can have multiple authors. So that is what these relations means. So you convert each of the attribute into a table like this. You show the primary key, then you show the relationship using the Crowfoot notations. Clear? Now we will build upon this. I'm taking this step by step. Okay. Now this is how you convert the ER model to relational model. Now when we were learning entity relationship model, we learned about composite. We learned about multi-valued keys, composite keys. Then we also learned about primary key, etc. Right? But when we were seeing the when we were seeing the ER model, we didn't represent that. Now let's see how we will represent all these in the ER model. If an attribute has a primary key, the primary key will have an underscore like this. It will be underlined like this. This means that for the for the entity employee, attribute employee ID is the primary key that uniquely identifies a record. So when you convert this employee into relational model table, your primary key is employee ID. Okay. Now, if you have multi-valued attributes, then if you have multi-valued attributes, then it comes in double order. If you have composite attributes, what is multi-valued? It can have more than one value, which means that you can have contact numbers, a phone number, or a mail ID, etc. If you have 2 values that can come for an attribute, it's called multi-valued. If you see 2 oval shapes, that means it's multi-valued. If you see an underline, that is a primary key. If you see 2 oval shapes, that is multi-valued. If it's a composite attribute, your attribute gets split into 2 again like this. First name, last name. This is how you represent multi-valued, composite, and primary key in your ER model. Great. Moving on. We are going to revisit the types of constraints. What is the impact of these constraints when you build a table out of it? The first one is the domain constraint. We learned, right? The attribute can take only value from its domain, and you can use null as and when required. The next one is the attribute value should be atomic, not composite or multi-valued. So you see here, right? When this employee table is built out of this ER model as a relational model table, your employee should contain first name and last name as the attributes. It shouldn't have employee name as the attribute, because your domain constraint says that the attribute values should be atomic. Clear? So that is how you convert an ER model to a relational model and eventually implement it as a table. So what does your domain constraint say? It says that the value should only be from the domain, and you can also use null. The attribute should be atomic. It shouldn't be composite or multi-valued. That is what domain constraints. Next comes the key constraints. What does key constraint mean here is there shouldn't be duplicate tuples in a relation. Basically, there shouldn't be duplicate records in a relation. There should be at least one attribute that differentiates a record from the other record. There should be at least one attribute that differentiates a record from the other record. And for that, you need a primary key, which is your second point. Every table should definitely have at least one primary key. And with the help of that primary key, you will be able to differentiate one record from the other record. And if all the values are same, then it's a duplicate record. That duplicate record, one of the duplicate or only one among those duplicate records should exist in your table. Clear? Next one is the entity integrity constraint, which is nothing but your primary key should not have null values. What is the meaning of null? Null means it's unknown, right? You don't know it. It doesn't mean that it's not available. It means that it's unknown to you. That is what null means. Null has a total different meaning from nothing. Null means it's unknown to you. It doesn't mean that it's not available or it's nothing, it's empty. It's something that is unknown to you. So when a primary key has null value, it tends to take every value as that unknown value, and hence primary key should not have null values. Your primary key should never have null value. Every table should have at least one primary key. And again, one more point to add, your primary key can be a combination of attributes. Okay. So for example, again, I'll share, before I forget, I'll share. Where is my Excel? So let's say student ID. Okay. CSE. CSE. What else? I can add here. Fact card. So CSE as a fact card as funny. EGC as a fact card. So the fact card as Ganesh, and the second one has a fact card as Amitabh. How will you uniquely identify a record here? Student name and fact card, correct? This two helps you to uniquely identify a record. This becomes your candidate key, and it will also become your primary key, which means that your primary key may or may not be one key. It can have a combination as well, depending upon how your table is. Understood? And that is why here it's written as primary key. It should have at least one primary key. Okay, there should be one attribute that works as a primary key. There can be multiple attributes that can identify as a primary key, maybe as a combination or individually, but there should be at least one. Okay, clear? And primary key cannot have null values. The entity integrity constraint means primary key cannot have null values. Key constraint means there shouldn't be duplicates. There should be one primary key. Domain constraint means the attribute should be from the domain. The last one is the referential integrity, which is nothing but your foreign key should exist in the base table as a primary key. Say, for example, let me again go back to the Excel sheet where we had this department ID. Okay, let's say that this is your department ID. Okay, this is your department table. Now I bring in another guy called as Suresh, and this department ID is free. This shouldn't happen. Why? Because your department ID is a foreign key for your employee table. It means that this key should have a corresponding reference in your department table, meaning there should be a record with department ID equal to 3, but it doesn't exist. This should never happen. This constraint that we put on the tables or relations is called as referential integrity. Clear? So first one is domain constraint, domain integrity, which means that the values should be only from the given domain, nulls are permitted. The second one is key constraint, which basically means that there should be at least one primary key, and this allows you to avoid the situation of having duplicate records. Third one is the entity integrity constraint, which basically means that your primary key cannot have null values. The last one is the referential integrity. It basically means that the foreign key of a table should have a reference in the referring table. It cannot remain as usually people use the word as orphan. There shouldn't be any orphan foreign key IDs. It should have a parent. Okay. So, moving on. I hope you are seeing my Excel. Sorry, you are seeing my PPT, right? Okay. Now, what have we done here? We have added the primary keys and the foreign keys. The author ID comes from author, and hence you see it as a blue key. There are different ways to represent it. It doesn't. That is why when you remember, if you remember the slide of your ER model, it was clearly mentioned that there is no industry standard followed for this. There are certain guidelines that we follow, but it changes from tools to tool or people to people or company to company. Okay, in certain places people just write N1, N0, etc. In certain cases people just draw only cardinality. They don't show the modality. In certain cases people draw modality and cardinality on both ends. Here you are seeing it only one end. Okay, there are no specific industry standards for it. So here you are seeing the foreign key with blue and golden color. In certain cases, it might be written in the brackets as F key. So here, only this much would be there. In certain cases, you have pictures, etc. It depends on the tool, but the idea would be there. Constraint violations. Let's see, whenever you do an operation, what are the different constraints that might get violated? So you have built a table, you have built a set of tables, you have defined the foreign keys, you have defined the primary keys, everything is done. Now, when you insert a record to a table, what are the different constraints that might get violated? Can you tell me which are the ones that might get violated? Out of these four constraints, which all might get violated when you try to insert a record? If you're trying to insert a wrong record in the wrong way, which of these four constraints can get violated or may get violated? Anyone?
Referential for sure get violated. And if we have, if we have like primary key already defined, then we will not have the issue with the third one and also with the second one. Domain, yes, that can also violate sometimes.
Okay. So again, let me just share the screen. Let's say that this is your table, okay, employee table, okay. Which is your, I also have an employee ID. Let's put it as 1, 2, 3, 4. Okay. Now, everything is correct here, right? Your employee ID is the primary key of this one. Your department ID is the foreign key. Your department ID is the primary key. Everything looks good, correct? Now, what if I try to insert null Rahul and department ID too? I can try to insert it, right? Definitely, I can try to insert it. And that is where your RDBMS, that software which manages your DB, throws an error telling that hey, there is a violation that is happening. What is that violation? It is, what is that violation?
Primary key.
Entity integrity violation. You are trying to insert a null value for a primary key. So when you insert, you can have an entity integrity violation, correct? Now, next one. So entity integrity we covered. Domain. I'm trying to insert employee ID A, employee name 939456, department ID F. This is domain constraint, correct? Domain violation. Am I right? Because A is not what the employee ID is. Employee ID is an integer. You're trying to insert a character to it. So it's coming out of the domain. So that is a issue here. So you can, while you do insert, you can violate the domain constraint. So you saw domain constraint getting violated, entity integrity getting violated. Now, see, I know your doubt would be, hey, I can't insert this record. That is because the RDBMS software sitting on top continuously checks for this, and that is why it throws you an error. Correct? Those integrity checks are implemented in your software. So when you go to Oracle and try to insert this, it throws you an error telling that this constraint is violated. That is the benefit of RDBMS. So that is the plus point of RDBMS, that RDBMS checks all this. It manages it for you. Okay, but you can try to insert it. When you try to insert it, if it violates, then RDBMS throws you an error. Hope it's clear that there is no confusion. So when you insert, you might violate the domain constraint, you might violate entity integrity, then you can violate foreign key, because we saw already an example, right? I put in 5, I put in Rahul again, and if I give a department ID 3, it's a foreign key violation. That is referential integrity violation. And then the last one is your key constraint. Nothing but you are trying to insert the same primary key, same value, etc. You have a duplicate. So what does this mean? This means that when you try to insert, all the 4 constraints might get violated. Yeah. So I don't know Hindi. I hope you are not. Okay. I hope it was not a quiz. Anyway, insert. There are all these 4 constraints that might get violated when you insert a record. You understood this, right? It can get violated. Who protects it from not getting violated? Your RDBMS, that software, your Oracle software, or your DBWare, or your MySQL workbench. That is that software that helps you to protect and insert statement from violating this. Clear? So when you insert, all the 4 constraints can get violated. So when you delete, can you tell me which all can get violated when you delete a record? When you delete a record, among these 4 constraints, referential for sure. Correct. Great. Because you might. Correct. Anything else? Anything else? Nothing, right? It's only referential integrity that gets violated. Now, you know the example. Let's say that you have employee ID 1 and department ID 4. You go to the department ID and you delete department ID 4, then you will have an orphan record in your employee table, correct? That is violation of referential integrity, correct? Because you don't have a reference in your department table for 4. How did that happen? You deleted a record from department table. How should this be handled? First, delete all those records which have department ID 4 from your employee table, then go and delete it from your department. So, if there is a reference, then go to the child table, delete the corresponding key, come to the parent table, delete the corresponding. That is how you manage it. Next one is update. Again, when you are trying to update a record, in a table, which all constraints might get violated?
All 4 of the insert.
Great, correct. It's same as what you do for insert. All the 4 constraints might get violated. Now, next one is select statement. When you run a select statement, which all can get violated?
Nothing.
Anyone?
Nothing. We are just
correct. Nothing. It's just a select statement. There is nothing that can be violated when you constrain that. No constraint violation happens during a select statement. Clear? So insert all the 4, delete just the referential integrity, and update again all the 4. Moving on. Okay, hold on a second. Give me a moment. Let me just clear out few people from place.
Excuse me, are you on mute or am I not getting the audio?
Yeah, I was on mute actually. I mean,
Okay,
I was
fine,
trying
thank
to
you.
clear off the background noise from my place. Sorry. I know it was getting disturbing. I mean, it was disturbing for few of them. Sorry, apologize for that. I'll just clear off right now. I hope it's clear now. There is no background noise now. Can anyone confirm?
Yeah. It's good.
Yeah.
It's good. Great. Okay. Now, so let me reshare this. Sharing the screen again. Give me a second. Let me know when you can see the screen. Are you able to see my screen, all of you? Hello?
Yes.
Yes. Okay, great. So now we learned about the different constraint violations that can also happen. Now, the next one is, how do you convert a relationship into a table? Okay, so first one is, let's see here, you have a ER model which has employee attribute, department attribute. What is the relation? Many to one. And what are the attributes? Employee ID, employee name for employee, department has department ID and department name. Okay. Now, when you are, and again, you see this underline, right? What does that mean? It means that for your employee entity, the primary attribute is employee ID. Okay. And for your department entity, the primary key is department ID. Okay. Understood up till this much. Now, what we are supposed to do? We are supposed to convert it into relational model tables. Okay. So the first thing that you do is you build the employee table. Your employee table has what are the columns? Employee ID, employee name, and the rest of the columns. And again, what is the primary key? Employee ID. You have represented it with an underline. Similarly, you build the department table as well. You have department ID, department name, and then you have the department ID as the primary key. All good, right? You have two columns. You have two tables with all the required columns. Now, how do you represent the relationship works for which has many to one relationship? How do you represent that? That is what we are going to see. We'll convert this relationship into the relational model table. So what does this relation mean? From employee to department, it's many to one, which means that an employee can be part of only one department, and a department can have n employees, correct? An employee can be part of only one department, and an employee can be part of only one department, and a department can have n employees. That is what this means, correct? Now, let's see where we will add the foreign key. Okay, let's try to see where we will add the foreign key. Let's first add it in department ID. So, what does the relation say? It says that an employee can be part of one department only, which means that employee ID 1001 Bob can be part of either department ID 1 or department ID 2, correct? Because he can be part of only one. It is a many to one relationship, correct? Clear up till this much? All same is the case for Sam. He can be of department 1 or department 2. All good up till this much?
Yes.
Okay. Now, if we try to add employee ID to the, so I'm trying to show you the different scenarios of adding the foreign keys. Okay. The first one is we added it to department ID. Okay. We added department ID to employee table. The next one is we are trying to do the same for department table. We will try to add employee ID to department table. Now, what is happening here? In your finance, you may have both the employees there, correct? Both Bob and Sam might be working for finance, which makes this employee ID column in your department table multi-valued, correct? It makes it multi-valued, which violates the basic constraint of relational model. Hence, you shouldn't be adding employee ID column to department table. Rather, you should be adding department ID to department column. This is how it will come. And your primary key, you can add department ID to your employee table, or you can create a new table altogether, which has two columns, which is employee ID and department ID, and the employee ID will become the primary key of that new table. It's up to you. You can do any of this. Clear? Any doubts? Should I repeat this? All are clear? Anyone, any doubts? See, if you understand one of these, the coming slides would be easier because it's a variation of same thing. All good with this?
What you
Okay,
said in the
I'll move to go ahead, please.
What you said in the department tables, that when we use employee ID.
Correct. So let's say that I'll explain it. So let's say that both Bob and Sam work for finance department. Okay. Let's say, for example, both Bob and Sam works for finance department. So if you are adding employee ID to department table, what happens? Your record 1 finance employee ID will have 2 values there, right? Because both of them are working for the same department.
Yes.
Which makes it multi-valued, which means that your attribute is having multiple values. And again, I'll try to go back to that slide. What does domain constraint say for relational model? attribute values should be atomic and not composite and multi-valued.
Yeah.
So you see here multi-valued. So it is a constraint violation as per relational model.
Okay,
Clear?
multi-valued. It should not be multi-valued in my case. Okay.
Correct.
Okay.
And so that is the reason why you shouldn't be adding department ID column, employee ID column to department table.
Department table. Yeah, yeah, got it. Okay. Right.
Now, if you add the department table to, if you add department ID to employee table, you are not violating anything there, right? Because it is not multi-valued or it is not composite. It doesn't violate anything. And hence, there are two ways to do it. The first one is either you add the department ID to your employee table, or you can create a new table altogether which has employee ID and department ID. But the point to remember here is employee ID should type your new table. Clear?
Yes.
Okay, so there are two ways to doing this. The first one is you add the department ID here, or you create a new table altogether with employee ID and department ID, wherein employee ID is the primary key of the table. It's up to our choice. It's up to us which should be which method to use. Okay, so this is many to one relationship. Now the next one is one to many relationship. What does one to many mean? An employee can be part of many departments. A department can have only one employee. Okay, what does that mean? Let's take an example. Your department can have an employee to department. An employee can be part of n departments, right? An employee can be part of n departments. A department can have at most one employee only. Okay, so let's see what happens if we add columns in both tables. First one, let's add department ID here. Bob can work for both department 1 and department 2. That is what 1 to n means, right? 1 to many. He can be part of multiple departments. So he can work for department 1 as well as department 2. Sam can also work for department 1 as well as 2. Now you see the problem here, right? The department ID column in this employee table becomes multi-valued. So obviously this is a problem. Now, how about if we add employee ID to the department table? Looks good, right? Employee, one department. What does this relation say? A department can have only one employee, which means that finance might have the employee 1001 or 1002, not both. It can have only one employee, which means that the ideal situation is to add your employee ID column to the department table. Or what is our condition? What would be the condition? You create a new table which has department ID and employee ID with department ID as your primary key. Now this is like the ulta version of what we saw earlier. It's the exact opposite reverse condition. Earlier the relation was n to 1. Now it is 1 to n. Earlier when it was n to 1, you added the department ID to employee table. Here you add the employee ID to department table. Now you might have seen a pattern here, right? You might have noticed the pattern. Wherever you see 1, you add the primary key of that into the opposite table. So here, where is 1 coming along with employee? You take that employee ID, add it to department table. In the previous case, where did you see the 1? In department. You take the department ID, add it to the employee table. So wherever you see 1, take the primary key from that entity, put it in the other entity. Okay, so here you see 1 near to department, take that, put it here. When it's the reverse case, you see 1 with employee, take that, put it here. And I hope everyone understood why we are doing it. because of the multi-valued attribute that it might create, which is a domain constraint violation as per the relationship model. Now, let's go to the next scenario where you have one-to-one relationship. Can anyone tell me where should I add the column? Anyone?
Either of them.
Either of them, exactly. You can have it as department ID gets added to employee ID, or employee ID gets added to department ID. It's up to us. Or even you can have a third table with employee ID and department ID, and you can choose any one of it as the primary key. What does this mean? An employee can be part of one department only, and a department can have only one employee, right? And so this is how it works. Now, let's go to the next set where you have many-to-many relation. What does that mean? Many-to-many relation means an employee can be part of N department, a department can have M employees. Okay. Now, this is the if you categorize it, this is the third case. Okay. Now, in this third case, what will you do? Let's see what happens when we add columns in either case. First, let's add department ID to employee ID. Bob can be part of department 1 and 2. Sam can be part of department 1 and 2. Hence, you get multi-valued there. If you add employee ID, finance can have both Bob and Sam. HR can have both Bob and Sam. Again, that also becomes multi-valued. So, you can't add either columns to either tables. You can't add department ID to the employee table, or you can't add the employee ID to the department table. The only way is you create a third table. You create a third table with employee ID and department ID as the attribute, and employee ID and department ID together becoming the primary key. In earlier cases, it was one or the other key. In this case, where you have many-to-many relationship, only option is you build a new table. You build a new table where both these keys together become the primary key, meaning 1001 and 1 will uniquely identify the record. 1001 alone cannot uniquely identify the record, or 1 alone cannot uniquely identify the record. All good? Understood? So, many to one, one to many. Idea is find out where one is, take the primary key from there, add it to the other table. One to one, either way, anything is fine. Many to many, no choice other than creating a new table with both the primary keys together forming the primary key of the third table. Okay. Now, let's say that you have a total relationship, which means that all the employees work for the, it is a one-to-one relationship and with total participation of department. What does that mean? The next is a special case where you have a one-to-one relationship with total participation of department. It means that every department has at least one employee. Okay, an employee is part of one department only. A department can have only one employee, and there is no department which doesn't have an employee. Okay, every department has at least one employee. Every department has only one employee. Every employee is part of one department only. In such cases, what happens is, let's add department ID to employee. 1 or 2. Same case here. Because it's one-to-one. Since there is total participation, if there is one more record, you bring it to, you create a new table with department ID as the value. Okay, so how will you create the new table is what I'll show you. Okay, so the department ID is 1 or 2 because one-to-one relationship, correct? Then you have employee ID added to it because total participation, sorry, here This is total participation. Sorry, I pressed the next arrow too much. So we were discussing one-to-one relationship with total participation of department. Means that every department has to have an employee and there is only one-to-one relationship. Now let's say that there is an employee Alex who doesn't have a department ID. That is an issue, right? Which means that you shouldn't be adding department ID to your employee table. Since it was one-to-one relationship, forget about total participation. You see this double line, right? This double line is what makes this total participation. What is total participation? Total participation means every department is actively participating in this relation, which means that if there is a department ID here, there is one employee tagged to it. Now, since this is one-to-one relationship, you could have added department ID column here or employee ID column here. Anyone would have worked. But since there is a total participation of department, let's take a case where you add an employee who doesn't have a department ID. That is going to create an issue, right? Referential integrity issue. So it's always preferred to create a third table with department ID as the primary key. Okay. Moving on, the next level to it is when you have one-to-one with total participation of both employee as well as department. It means that all the employees are tagged to one or the other department. Every department has at least one employee tagged to it, and there is only one employee who is tagged to a department, and only one department for each employee. So one-to-one with total participation. These are all special cases. It's just for your information. I don't see a situation where it might happen in real life, but just for your understanding. Okay, this could have been added, but the same problem of whether there could be a department which doesn't have an employee can come, and an employee which doesn't have a department can come. Hence, the ideal solution is you create a new table which is a combination of all these values. You have employee ID, department ID, employee name, and department name, with either the employee ID or the department ID becoming the primary key. Next are certain things there are some things called as weak entity, strong entity, identifying relationship, etc., which we will try to understand. Now, you see two entities here, right? Employee and relative. The relative of an employee is what the relationship is. A relative can have relative name, age, type of relation. And this relative is in total participation. All the relatives are some way or the other related to one of the employee, and hence it's a total participation. Employee has the employee ID and employee name. An entity which doesn't have a prime attribute is called as a weak entity. An entity which has a prime attribute is called as a strong entity. In this case here, your employee is a strong entity because it has employee ID as the primary key. Your relative is a weak entity because it doesn't have a primary key. Now you might be thinking, why it doesn't have a primary key? Why can't I keep relative name as the primary key? Let's take an example and see. And if an entity is a weak entity, you show it in two rectangles, double rectangle. Okay. This double rectangle means that this entity is a weak entity. It doesn't have a primary attribute. Okay. Let's see the employee table and let's go to the relative table. The relative can be Alex, age 55, father, Jack, age, son, etc. What you're supposed to do is you have to create a new table with employee ID and relative name as the primary key. Okay. Why? Because tomorrow you can have another record with the same name, same age, and same type of relation, but that might be to another employee, right? There can be two employees who are having the same name for their son, same age, and same relation, right? Now, how can you manage that? Create a new table which has employee ID and relative name as the primary key. Now, this entity relative, which is shown in double rectangle, is a weak entity. Why? Because it's a weak entity, it doesn't have a primary attribute. This with a single rectangle is a strong entity because it has a primary attribute, which is employee ID. How do you manage this? You manage it by using something called as the partial key, which is one of these attributes acts as the partial key for the new table that is created. And what is the partial key here? The relative name. Okay, and you represent that partial key with dotted underline. Dotted underline means partial key. What does partial key mean? It is not a primary key, but when it combines with the primary key of the other entity, together they become the primary key for the new table. Such key is called as partial key. Partial key always comes along with weak entity, which is represented by double rectangle. This relationship is now called as the identifying relationship. A relationship between a weak entity and a strong entity, where the weak entity is in total participation and the weak entity has a partial key, is called as an identifying relationship and is represented by double diamond. So many doubles coming here. Earlier we saw double oval. What was that? Multi-valued. Double oval stands for multi-valued. Double diamond stands for identifying relationship. Partial key presence as well as total relationship of a weak entity with a strong entity is called as an identifying relationship, represented by two diamond shapes. Weak entity is represented by two rectangles. Partial key is represented by dotted lines. Primary key, single underline. Next is the different types of relationships. You see an entity and this relationship has two entities. If it is two entities, this relationship is called as binary. If it has more than two entities, it is called as n-ary relationships. If it is 3, you call it as tertiary. If it is 4, you call it as quad relationship, and so on. It's usually called as n-ary relationship. If it is 2, you call it as binary relationship. A relationship, if there are the number of entities in a relationship, defines the relationship, n-ary relationship. If it's 2, you call it as binary. If it is more than that, you usually term it as n-ary relationship. Okay. Now, when you build tables for n-ary relationship, you build it like this, right? For E1, you have A1 and A2 as the primary key. A1 and A2 as the attribute, and your primary key is A1. For E2, it's A3 and A4, E3, A5 and A6, E4, it's A7 and A8. Now, how do you show the relationship R1? You build a new table which has all the primary keys, and the combination of this becomes the primary key for that table. That's how you build relationships for n-ary relations. What if you have composite and multi-valued data in your ER model? How will you convert it into relation model, into tables? You'll see it right now. So for E1, it would have been attributes A1 and A2 with A1 as the primary key. But what is the problem here? Your A2 is a composite key, which means that it can be further subdivided into A21 and A22. Again, what does this mean? This violates the constraint that an attribute in your relation should be atomic. Hence, this is not possible. How can you rectify it? Very simple. Split it into two columns. Keep it as two columns. Now, for E2, what is the problem here? Your A5, right? Your A5 has multiple values, correct? Multi-valued and composite should not be present in your relation. So when you create E2, what you would do is you will just keep A3 and A4. You will park A5. You will not add it to the table. Now, what is the relationship? How will you add key? you add A1 here, and then you have the relationship going on. Now, in order to bring in A5, what you do is you build a new table which has A3 and A5, and A3 and A5 together becomes the primary key. So that for one A3 you have one value of A5, and for the same A3 you have another record with the same value. So you have multiple records for A3, and in the E2 table there will be only one record for A3. Understood? This is how you manage the multi-valued and composite. Composite, you split it, you add it as an extra column. Multi-valued, you add a new table, you create a new table, you take the primary key of the entity which has the multiple values, that becomes one column, and the multi-valued key becomes the other column. Together, these two becomes the primary key of the new table. Now the last among this, where your relationships also has an attribute. So whatever that you saw right now till now was your entity has an attribute, the entity has attributes, but here you also have attributes for your relation. How will you implement that in your table? So rest everything is very pretty much straightforward. You have employee table, you have department table, it's n-to-1. So obviously where would you add? In the employee part, right? Now it's n-to-1, right? So where is one coming? Department. You take the department ID and you add it to employee. That is what you are going to do eventually for showing the relationship between department and employee. But here works for this relationship also has an attribute. Let's say that Sam's shift timing is 10 a.m. to 6 p.m. and Bob's shift timing is 6 p.m. to 2 a.m. So you added the department ID here. If departments, both of them are working for the same department, if you add the shift timing to department table as an attribute, it will create multi-valued attribute, right? Now let's add that to employee table. No issues, correct? So what you have to do is your final table, this attribute should go to the employee table. Again, it's very simple logic. If you have a relationship like this, check for where one is. Okay, department has one along with it. So you take the department ID, you add it to employee table. You do the same for the relationship also. You add it. This is your final table. This is how you show the relationship here. Now let's take the other case where you have one-to-one. Again, you might have already guessed, since it is one-to-one, you can add it anywhere. It doesn't matter. Clear? I don't have to explain it, right? It's just a build on top of the previous cases. Now comes the complicated cases. Earlier, when you had end-to-end relationship, what did you do? There was only one option. You build a new table which had department ID and employee ID as the primary key. So the same logic goes here. You add it, that's it. You add that shift attribute also to that new table where your employee ID and department ID. It's just an add-on to what we were doing. That's all. Okay. Any doubts? Any doubts, anyone? I know there were so many things, but if you have got one logic, if you have understood one logic, then it's easy to apply it to the other logic. After this session, when you go through the PPTs, for the first slide, just understand it. For the second slide, it's all click and then it comes up. So put it in full screen mode, click, see what is happening, and then guess or think what should happen and check whether it's happening the same way. Okay, if you have got one logic, that's quite enough because it's easy to relate all the other and build the other ones. All good?
Naril, Ganesh here.
Yes.
In the earlier slides, yeah. So in the earlier slides where you put a 0, not here. I mean, you need not go back. In the morning session, I believe. So where you had 0 or a circle to say like What was that actually? I am trying to recollect.
It is called as crow's foot notation. That is, okay, I'll tell the difference. I know where the confusion is. Crow's foot notation is actually where you are drawing and showing a pictorial representation of how your table would look like and what is the relationship. It's a diagrammatic representation. What you are seeing in these slides is the actual implementation of the table. When you are building a table in the DB, how should you build it? Okay. The other one is called as Crowfoot's notation. I'll go back and I'll show it. This is what you're asking for, right? What you see here.
Correct.
This is called as crowfoot. If you see here, it looks like the foot of a crow, right? That is why it is called as crowfoot notation. Crowfoot notation. Let me just bring that slide out.
You said that I actually heard a crow sound also.
Actually, you are hearing one because I'm sitting outside now because it's very difficult to send the kids out because it's too hot. So I thought I'll come out, let everyone sit inside.
Okay.
So I'm sitting in my garden and I'm taking the session now. So this is what your crow's foot notation is. You can see here, right? Crow's foot notation.
Okay.
This is used for diagrammatic representation of your relational model. What we were seeing is when you convert that diagrammatic representation into actual implementation, as in when you create a table, you write the DDL statements and you create the table in your DB, how will you implement these relationships? That is what we were seeing right now. Okay.
And do you also define in a relationship that something cannot have? You always say like, you know, 1, n, etc. Right? So is there something that says like, you know, a particular attribute cannot be there? For example, a department cannot have a illiterate person or a person like, who doesn't have a particular qualification.
So that is actually something called as check constraint. Okay, that you implement at your table level. What does check constraint do is you put a constraint on top of table telling that, say for example, you are building a list of people who can vote in your locality. You collect everyone's detail and you put a check constraint telling that if the age is not above 18, don't let them insert it. So that is called as check constraint. Okay, that happens at the table level. That happens while you implement the relational model in your DB as a table. There you write the check constraint. That is extra thing. It is not part of your domain constraint or entity integrity constraint. It is not part of your model constraint or relational. It is not part of your relational model constraint. It's actually a constraint that is defined by you based on your requirement, right? It's something that came up as part of your business, correct? And hence it is called as check constraint, and that would be implemented on top of your table only when you create that table.
Okay. Sure.
Okay. Just a recap of all the symbols that we saw. There were so many symbols. So the last slide is a recap of all those symbols. Just go through the slide. I know there were so many slides, but once when you go through it, you will be able to recollect what is happening and you will be able to connect the logic as well. An entity is represented by a rectangle box. A relationship is represented by a diamond. An attribute is represented by a oval shape. A prime attribute will have an underline inside the oval shape. A multi-valued attribute is represented by a double oval shape. A composite attribute is represented by an attribute splitted into two. A weak entity is represented by double rectangle. An identifying relationship is represented by double diamond. All good?
Sir, can you explain the identifying relationship again? The last one.
Sure, sure. So let me go back to that slide again. This one. Okay. So let me start from the beginning again. Let's say that you have two entities, relative and employee. The relationship is relative of an employee. Employee has the primary key employee ID. Relative doesn't have a primary key. But all the relatives are one way or the other connected to an employee. Hence, it is total relationship. Okay, and that is why you are representing it as two double lines. Clear? This is how it is. Now, what is a strong entity? A strong entity is an entity which has a primary key. Employee is a strong entity. And weak entity, hey, give me a second, hold on a second. ശനിയാഴ്ചയല്ലേ ഉണ്ടോ അഞ്ഞൂറ് അങ്ങോട്ട് ഉണ്ടായിരുന്നു അതിൻ്റെ ഒരു 100 മാറ്റി sorry for that. Okay, so relative is a weak entity. Why? Because it doesn't have a primary key. I'll show you with the example of table. So if you see here, the relative table, you can have Jack, 8 and Son for 2 records, but might be connected to 2 different employees, right? One of these Jack might have been connected to Bob and the other one is the son of Sam. So there is no primary key that is defined for it. Such entity which doesn't have a primary key is called as a weak entity. Weak entity is represented by double rectangle. Okay, and a weak entity can be connected to a strong entity by defining a new table wherein one of the attribute becomes the partial key for the primary key of this table. What is the partial key here? Relative name. Because your primary key here is employee ID and relative name together. So where did this relative name came from? It came from the weak entity relative. Hence, this relative name attribute is called as the partial key. It is represented by dotted line. Okay. Now, any relation between a weak entity and a strong entity wherein the weak entity is in total participation in that relationship is called as an identifying relationship. I'll come again, very simple. Go through the picture as well. You have a weak entity which is relative. You understood why it is a weak entity, right? Because it doesn't have a primary key. If you take relative name Jack, there are 2 records. If you take age 8, there are 2 records. If you take son, there are 2 records. If you take any combination of these columns also, you have 2 records. Correct? Hence, it doesn't have a primary key of its own. So when you are trying to convert this ER model diagram, when you are trying to implement it as a table, it will definitely violate the constraint of which constraint? Key constraint. You cannot have duplicate values. That key constraint gets violated. Correct? Hence, what we should do is we should create a table like this where employee ID and relative name together becomes your primary key. Okay, and this relative name came from this entity and hence this is called as partial key. Okay, and definition of identifying relationship is if a weak entity is in total participation with a strong entity in a relationship, then that relationship is called as identifying relationship. If a weak entity is in in a relationship with a strong entity such that the weak entity is participating totally, then this relationship is called as an identifying relationship. And it is represented by double diamond. Clear?
Thank you.
Oh, great. Any questions, anyone? Again, I know that there was too much to digest at a go, but please go through the slides again and it will become easier. It is all connected. You understand one, the rest becomes easy. Okay. Next one is exercise. Before that, yeah, let's. I think most of you might have got a bit bored. So what I'll do is I'll just make it. I'll just run a small quiz. Okay, it's not evaluated. It's, I mean, in the sense it's not. It's just for fun purpose. I'm not taking the marks or anything. Okay. Uh, Second, okay, okay, that is my Q1 share. So I'm going to paste a link in our Teams chat. Let me know if you can. Can I paste something here? I don't have the permission to chat. That's really bad. I can't share anything. I can't chat with people. Oh.
Sir, I think you have to be promoted.
Can you please promote me? Give me a promotion. Recording and transmission as you are an activity. Who has the contact? Yes, please.
Already present. Is there a setting for that? I'm just checking.
Yeah, please.
I think it's because the account which you've been using is a guest account, right?
Oh, okay.
That's one.
Okay, so I'll do one thing, Rojal. I'll just put it across to you so that can you share it in the group?
Yeah, that one.
Share it in the group in the sense I need. Can you share it in this chat?
Yeah, I can do that.
Yeah, I'll do that. Let me just ping it to you.
So can you just try again?
Yeah, let me check. Chat. I do not have an option for chat itself. I just joined in as a guest. That is the problem. That might be the problem. Yeah. Let me just quickly grab my phone and then I'll send it across. Phone. Whom should I send it to? Amin?
Yeah, you can send it to me, sir.
Okay, great. Okay. And share, copy link, copied. Okay, just click on that link. It might ask you to enter a name. Just give your name. Okay.
Okay, just a minute. Okay, link. Yeah, it is asking. I'll just put my name.
I can see one of them joined. Yeah. One F360. I don't know who that is.
Yeah, it says that get ready to play. So.
Yeah. Okay, just wait. But I just see only one person.
Is it Kahoot?
It's not Kahoot. It's Mentimeter. Similar to Kahoot, but Kahoot is kind of a difficult thing, right? You need to look into the screen and then tap on your phone. So I thought.
Yeah.
I've shared the link here in the chat.
Yeah, I can see people joining in. 10 of them have joined. Eleven, 12, 13, 14, 31 left. Someone went back. 8, 15. How many of them are there actually attending the class? I don't know. I'll have to check.
I think we have a combined
20.
class.
Yeah, 25. I think 25 people, including me. So probably it's 24. And then Amin and Rujul is also there. So I reduced another 22 people probably. Okay, so I'll start in a minute. All those who are yet to join, please join in quickly. Okay, I'll just get started. I think we have 19 people. We'll get started. Okay, so what is going to happen is you will have a question. You will have 4 options. Again, it's more or less like a fastest finger. Whoever who answers fast would get more points. Whoever who answers would get points. But then, depending on how fast you are, you will get more points. Let's see how it goes. Okay, just to, I mean,
I'm not able to see any screen is showing loading. But
yes. Yeah. I have not started the game because I see people joining in and then leaving and then joining in again. So I have not started. Okay, I'm going to start. After I start, no one else can join. So I'm going to start in another 5, 4, 3, 2, 1, go. Okay. You might be seeing answer fast to get more points, right? Everyone has voted. 12 of them have answered it correctly. Double oval is multi-valued attribute. If there are multiple values for, like, say, for example, phone number, if you have multiple values in the ER model, you show them as double oval. Let's see after the first question, who is leading. Okay. And with 949 points, Krish is leading, followed by Ganesh, followed by Trinish. Okay. Let's see after the second question how it changes. Second question on your screen now. There is one more who's yet to vote. The time is and everyone has voted. The correct answer is identifying a relationship. Identifying a relationship. When you have double diamonds, diamonds are the ones that are used to represent relationship. If there is double diamond, that means it's an identifying relationship. Okay, so let's see how has the leaderboard changed now. Krish, who was leading, has anyone overtaken Krish?
Marimal, are you sharing the screen?
They can see it in their screen, actually, Dr. Chin.
Okay, somebody can share this?
I can share, I can share, I can share.
I am still in first place.
Congratulations.
Okay, so it's still Krish who is leading again. I think Tejaswini sneaked in. Tranish, I think you got it wrong. Drop down. So let's see. Next, only top 10 would be on. I'm sorry, this Mentimeter is like a free version, so it has its own limitations. Now, next question. Which constraint enforces that there shouldn't be duplicates in your relation? Domain constraint, entity integrity, key, referential. Which one? You have 7 more seconds. 5, 4, 3. Okay, there are few of them who didn't vote. It is key constraint, right? What is your domain constraint say? It should be only from your domain, or it can have a null value. What is entity integrity say? It says that your primary key cannot have null values. What does your key constraint say? It says that there shouldn't be any duplicates, and hence you should have a primary key. What does your referential integrity say? It says that your foreign key should be referencing to a primary key of another table. Okay, 11 of them have got it right. Let's see whether there is any change in the leaderboard. Well, the leaderboard has changed dramatically with Tejaswini leading now, followed by Bhavana, followed by Venkataramana. And points are pretty close. The topper and first rank and second rank are like just 200 points. Again, the competition is still tight between the first 5 people. Let's see. Question number 4, you only have 2 more questions including this, question number 4 and question number 5. Okay, so let's see how it goes for the fourth question. This is a check whether you listened to me at least like 5 minutes back, 2 minutes back. Come on. If not, if everyone doesn't vote, I'll be highly disappointed. Not everyone has voted. Again, let's start from the beginning. Key constraint says that, what does key constraint say? There shouldn't be any duplicate keys. There shouldn't be any duplicate records. There should be at least one primary key. That is what key is. Entity integrity says that your primary key cannot have null values. Your domain constraint says that the value of an attribute should come from its domain plus null. Referential integrity says that your primary key, your foreign key of an attribute of a table should refer to a primary key of another table. Okay, so the right answer here is entity integrity. Only 5 of them have answered. Let's see how the leaderboard has changed. I mean, 3 among the top. Okay, so Tejaswini still remains. I'm sorry. Tejaswini still remains first. Venkada has jumped. Bhavana third. Krish is fourth. Ganesh is fifth. Amin has jumped to sixth. And in this round, Amin was the fastest to answer. Last question. Let's see how it goes.
Fastest finger is like when you get too excited, you just click quickly.
Right answer is domain. I know I have purposely was not telling this because I know this question was there. It is in your domain constraint that the attribute cannot be the attribute has to be atomic value constant. Again, it's kind of easily guessable, right? Entity integrity relates to something that is for primary key. Referential integrity is again primary key and foreign key. Key is where you can't have null values for key. So where would the attribute being atomic would come in? It has to be in domain, right? Okay. So after the final round of question, winner for this quiz is still Tejaswini because she made a lot of lead in the last few rounds. So Tejaswini becomes first, Ramana becomes second, Bhavana becomes third, and so on. It was just for fun purpose, okay? So I just wanted to check whether, to bring out of that boring theory sessions, I thought I'll have this refresher quiz. It has nothing to do with your, what I should say, evaluations or anything, okay? No worries. Just for fun. Do we want one more round? No, it's boring, right? It's okay.
I think so.
We'll finish up one more topic and then we'll have one more round then. Okay. Cool. So it's 3:44. I'll give you a break now. We'll connect back at 4 o'clock. We will start with the hands-on. Meanwhile, I guess there is one file called as data dict that has already been uploaded in the LMS. Please download it and keep it ready with you in your system. Okay. Data dict, DATA data dictionary. Okay, it's already uploaded in LMS. Please download it and keep it ready with your system. We'll have a 15-minute break till 4 o'clock. Okay. Okay.
I was disconnected. Can you repeat what you just said?
So we'll have a break for 15 minutes till 4 o'clock. Okay. Why before you break, before you leave the system, there is one file in your LMS, an Excel file, which is with the name data dict, DATADICT. Please download it and keep it ready in your system. Okay.
Where is it in LMS?
It is inside learning material.
So if it's an Excel file, it shows corrupted for me.
Okay. You're not able to download it, is it?
So I mean, I shared my screen.
Yeah, sure. Go on.
I have downloaded it, but I get this.
Okay, what I'll do is maybe it's just a conversion because maybe from a Mac usually happens when we upload it from a Mac. And
Okay. But for the other group, they will have it in the respective places, right? Somebody was asking question where it is published.
Yeah, and in the same place. What I can do is, can I upload it here itself? Let me try uploading documents. Okay, I'll upload it in the no, there's no option here. Okay, we'll upload in
Excel must for this, or you have an option to publish as a PDF.
the Excel, right? You wanted the Excel, right? That one.
Oh,
the one. I'm just gonna upload it again.
I think you can post it here also, right?
The posting a document, the option is not coming here for the Teams for some reason. I'm not sure. So what I'll do is I'll change the file itself. Downloaded it. Just a minute. Okay. Yeah. Yeah. Can you refresh your page and check?
I'll try that.
Oh, where in LMS is this? Because I'm not able to find it, under the in-class materials for module 3.
Module 3. It's there in classmate. Is it for
So
AI?
I have shared my
For
screen.
BA10. For BA10.
For BA10, I'm not sure if it's there or not. Let me check for BA03. Right.
It isn't on LMS.
Yeah. No issues. We'll upload it there. Let me just really. Ganesh, you're able to download it, right?
Downloading was happening before too.
How is that
Opening
opening?
was. Yeah, I'm going there.
I'll upload till then. I'll upload it in 10 minutes.
The same error I am still seeing.
Same, is it?
Yeah.
Okay, no issues. I'll just post it in the group. You can access it from there.
Yeah. Same error.
Same error for me, data dict.
Not sure why.
I thought I'll copy the content directly from the LMS, but the formatting goes for a toss.
Yeah. Always an issue with the Mac. It gets converted automatically and then. Check now if you are able to access. I've shared it in the team.
Can you save as a CSV file or something if the conversion is the issue?
Okay, I can do that. Just try once accessing the file. And then. Okay, for B010.
I mean, I can access from the WhatsApp. It works for me.
It's opening, right? Yeah. I think it's just that when I'm trying to upload it from a Mac, it's just getting corrupted there. Not sure why. You can, yeah, AI people can access from the WhatsApp group.
Yeah, so for me also the WhatsApp one works.
Yeah. For PA010, is it working? Can you refresh and check?
Yes, it's present now.
Okay. All right.
we'll get started. I hope everyone has downloaded the Excel sheet.
Yes.
Show you the Excel sheet, right? Okay, so what you see here is a set of data points that let's imagine that you are in a company and you are in a telecom company, and your data engineer has collected a set of data points, and you have got those data points. You are basically told that, hey, these are the metrics that we are going to collect, that we are going to bring in, and you can do your analysis using these data points. So we'll go in the fashion how we will be implementing a relational model, and from there how it is implemented in your database. Okay, so this is kind of an exercise. The first part, you guys think how you will create a table, and forget about the ER diagram. Okay, just bring in the relational model diagram. Relational model diagram is where you have the table name, the foreign key, the primary key, the cross foot notation, etc. Right? Think about how many tables you need, which all table will have what all attributes. You can give the table name as for your choice. Keep the metric names as it is. If it's custody, keep it as custody itself. Okay, so think about that. Think how many tables you would need. Think about all those constraints that might come into picture, and then try to come up with a ER relational model diagram where you have the tables and the Crowfoot's model. Can you try that? Just take a pen and paper and try drawing it. We'll spend like 10 minutes for that, and then I will also start drawing it. Now, again, before, okay, what do I want you to draw? Okay, start drawing it with your pen, and then I'll introduce to a tool where you can draw it in your system. So while you are going through the data dictionary and thinking about the different tables, I'll explain what it's kind of self-explanatory, the description, but again, I'll explain what it is. Customer ID, it's again a unique ID that identifies each customer. Gender, male or female, there are 2 values. Forget about other values. Let's consider that the data set is going to have only male or female. Senior citizen, if the customer is has an age greater than 65, you get an yes, else it's no. Partner means if there is a partner to that particular customer, whether he has a spouse or a partner, yes or no. Dependents, in addition to partner, whether there are other dependents like children, parents, grandparents, etc. Yes or no. Then comes the state, the place where the customer, the state in which the customer is staying, latitude and longitude of the location, zip code of the residence. Then you have the different services. Phone services indicates where the customer subscribes to home phone service with the company. So there are multiple services that the telecom is giving to the customer, and these set of services like phone service, multiple lines, internet security, etc. are different services that are provided by the telecom. And yes or no says whether the customer has a subscription to it or not. Then moving on, after all those services are done, then you have the tenure. Tenure basically says for how many months the customer has been part of the company, the telecom company. Okay. Then you have contract, whether he has a month-to-month contract, 1 year contract, 2 year contract, whether he pays bills monthly or yearly or 2 yearly, etc. That's what contract is. The payment method, whether it's paperless billing or not. Paperless billing, whether it's used using bank withdrawal, credit card, mailed check, etc. Monthly charges, what is the charge that is incurred by the user on a monthly basis? If so, the total charges is, let's say that you have been part of the telecom company for 5 months, your monthly charge is 200, your total charge is 1000 rupees. Churn is the most important column, which basically says whether that customer churned or not. If it is yes, it means that that particular customer has left the company. If it's no, that particular customer is still in the company, with the telecom company. What is the relevance of this data? You analyze this data, the data scientist runs models on top of this, and they will be able to identify the customers outside of the test sample, outside of the training sample or the actual data set, and identify those potential churnable customers. Okay, that is the idea behind this. But we'll start from here and then we'll connect till the end and you will get why we are doing all this. So as the first step, let's build the relational model diagram for this. You can have as many number of tables as you wish, but there should be a logic to it. There should be how should I put it? All the constraints should be strictly followed. Keep all that in mind, and then and in your diagram, try to show what kind of relationship does the tables have. So to get it started, I'll give you an example. Okay, let's say that you create a table customer ID, gender, citizen, partner, dependents as one table, and you call it as customer. Okay, and obviously your table would be a square, or it's not a square, a rectangle box which has customer as a table name. Then you have each of the fields written, and your customer ID, since it's the unique ID, it will be in it will have a primary key notification, something to notify that it's a primary key. Either you write it as PK in bracket or you make it bold, etc. Okay, so that is your first table. Now let's say another table, you have the customer location. It has state, latitude, longitude, and zip code. Now, what column should be added so that it gets connected to customer table? And what is that relationship? Whether it's many to one, one to many, etc. Think about that. Create tables like that. Show the relationships. Show the different tables. This is what we are supposed to do. First, do it on a pen and paper. Then I'll introduce to a tool where you can do it. There are multiple tools that are available. In fact, there are certain RDBMS that helps you to build ER diagram out of the tables, etc. We'll see those scenarios. Any questions, anyone? Sorry, it was more like a radio. I was speaking. I was not even asking whether anyone has an issue following or not. Any issues? Any questions?
You said to create table among these information we have, relationship table.
Correct. So I'll show you an example, just like what you. Let me just share this again. Share PPT. You're seeing my screen, right? Something similar to this. Again, as I told, this is not for evaluation. It's how it's a learning thing. It's an exercise, so you don't have to worry about submitting it and all those things. It's not part of the evaluation. Meanwhile, I also really wholeheartedly apologize for those background noise that was happening. I have a 3-year-old kid, and the cousins came in, and he was like super excited. You know how it is going with this home, with work from home. There is no traveling and all. So when my brother came, he was so excited. And really, I really apologize for the background noise. I know that it was disturbing for few of them. Uh, Sorry, I really apologize for that. This I'll make sure that this doesn't happen. Obviously, this won't happen next time because they won't be here. But still, I apologize for that. Has anyone used Cisco WebEx, or is anyone using Cisco WebEx in your office, or is everyone using Zoom or Microsoft Teams? Anyone using Cisco WebEx?
We have been using. Yes, Mary, I am using Ganesh here.
Yeah. Okay. So, what? No, I'm not trying to sell Cisco here, but there is Cisco WebEx. A couple of months had an update. What it does is it cancels the background noise, and so in our meetings, what usually initially happens is when there is some construction work or when the kids are making noise, we would ask whether they are hearing the disturbance, and everyone used to say, no, we are not hearing anything. But because of that, AI that is running behind, and so I'm used to having my kids making noise in the background, and then not being disturbed in the meeting as well. So I'm trying to protect myself here.
There is also a noise suppression in the device settings in Microsoft Teams. You can try that.
Oh, okay. Let me just check. When you are creating that, you can create this. Show device settings.
Mary, I have posted in the chat. You can see.
Thank you, but the problem is I won't be able to see the chat because I logged in as a guest. But that's okay. That's okay. Okay, so what we'll do is we'll just get started. Okay, so again, I ping in the WhatsApp group link. Okay, there are two groups, right? I'll ping those link here. This is one of the most commonly used online tool This is PGDM MBA BA10 and PGD MTech MSc AI03, right?
You are right.
Putting it in WhatsApp. Okay. MBA. If at all someone is kind enough, please share that in the chat as well, in the Teams chat, so that it becomes easy for everyone to access it. Meanwhile, let me share my screen to show you this. So this is a tool called as the dbdiagram.io. See, there are multiple tools available. It's just one among those. I'm just using it to as I felt it to be convenient. That's all. You can use MySQL Workbench and do a reverse engineer to get the ER diagram. There are multiple ways to do it. This is just one among. I do not enforce anyone to stick on this. Whichever you feel comfortable, you can use that. Okay. Now, if you click here, already one ER diagram is there, and it shows you how you can create all this. Okay. So the format is very simple. Table is the keyword. You keep the table name. If you want to give an alias, you can give that. Then you have curly bracket starting. You represent the ID. What is the represent the key, the data type. If it's a primary key, if it's incremental, etc. Okay, that is how you do it. So let's start with our data set. Okay, let me share the Excel again, and we will logically think about it and then get started. Okay, share screen. Okay, now as I told, customer ID, all these things, first thing that we have to do is we have to go through the entire data set like this and think how you can logically combine them into a single table, or how many tables, etc. would come in. So when you go through the data, you see the first few columns corresponds to the customer, right? The customer's detail is the customer detail, right? So let's group them. Make it a new column, and let's call the table. Let's group them as a single one. And let's, for the sake of it, call it as customer. And for that, let this be the primary key because it's uniquely identified. Now, all these things corresponds to a location where the customer is located. Correct? So this can come as another table. Another table. Okay, going to merge send. Let's call it as maybe cost location. Okay, that also looks good. The next thing is all these things. Yes, I know your question. We'll come to that. Right, we need to add one more column. That is why I have kept a space here. I know that. We'll come to that later. Okay, all good. Okay, now what is this? All these are the services that are taken by the customer. So why not we separate it out? Okay, and
Sir, why do you want to separate it? Why not to club it with the customer?
Club it with the customer. Okay, I'll tell you why.
Yes.
Okay, if you say that, if let's say that if in this case it might work because the relationship comes eventually as one to one. Okay, but in cases where you have many to one or one to many, there will be redundant data. For example, just as we had seen it here. Okay, the employee table. Are you seeing the employee table? Are you seeing the Excel where we have the employee table and the department table, everyone?
Yes.
So let's say that what was given to you was employee name, employee ID, you had the employee name, you had the department name, You add the department head, you add the department office location. This is what was given to you. Okay. Now you could have kept it as a single table, but if we keep that as a single table, these values might repeat. Correct? Hence, you divide it into two tables, making sense to avoid the redundancy of data. Now, in this case, since it's a one-to-one relation, see that eventually would come. You won't know it whether it is a one-to-one relation right now. Only when the data comes into picture or when you start building the tables, you will know that, hey, this is going to be a one-to-one relation. Hence, if you keep it there, it's okay. Okay. So to answer your question, why do you have to split it? In this case, no, you don't have to split it. But it's always suggested that you split it into different tables so that each of this table corresponds to a particular subject. As in, here you are getting the customer details. Here you are getting the customer location. Here you are getting what all services, the customer services. Okay.
Sir, you are right, but the thing is, if I have to do a performance tuning, I won't like to go for extra join because it will take some more time. And evidently, if you see check the plan for it, it will internally the SQL engine will internally treat as a one. So first time it will take some more
What
time,
if
but
you are
afterwards,
supposed to do? Yeah, what if you are supposed to do a lot of updates on it? If it's an OLTP debt, will you split it or
yeah.
not? Right. So again, the answer is
Since
it
this
depends.
is structured data and there is always a one-on-one correspondence, I will never split it because the retrieval will be very easy.
Structured data, not all structured data are one-on-one. This specific case is one-on-one, so you don't have to split it.
Yes.
That's it.
Yeah.
Only in this case, but it's usually suggested that if you are doing overlap, you need not denormalize. You can denormalize it, meaning you can combine it together. If you are going for your RDBMS, people suggest that it is normalized. Okay, the simple rule is if you are using RDBMS, stick on to normalization. Normalization say that you split dimensions tables as such, you have a fact table, etc. Okay, again,
I can add something like
yes.
Currently, like if you are operating in India, but later on business make it their business in the USA, then US address norms are different. They have like province. They don't have something like the kind of structure which we have in India. If you have just one table, you will end up uh, like modifying all the records. I mean, you will touch the main table. But if you have divided, then if you are opening the business in US, then the address will only get changed. Then you will just add the column in the address table. Like, okay, to operate in the US, we have to add one more column in the address table. Similarly, currently they have like some kind of services, like 6 or 7 services. Later on, if they want to introduce one more services or they want to just reduce, so they can just manipulate that particular table. They don't have to just touch the entire data set.
Thank you.
Actually, I won't go with this. The reason is if
you see the business data, most of the time
no,
they
no,
are
no,
like
no,
this
no.
only.
From
They are splitting the
there are
data.
total number of 26 attributes. I will
For
have
performance,
to
for
if I will
performance training, we have
go with the
multiple
designing.
things. Krishna, for performance training, we have multiple things. If you are like presenting data to the stakeholders, and if it is going like on a schedule basis, we have the kind of materialized view where you will get the data within a second. So for performance wise, we have different scenarios, different strategies.
It all depends on you. If you, I mean, whichever, see, the usual rule that we follow in RDBMS is try to split it into different tables so that there is more independence between the tables. As ma'am just mentioned, it's easy for update. doesn't mean that you have to completely follow it. If you are doing some analytical purpose, it makes more sense to have denormalized data as a single table. This entire thing as a single table. You are worried only about the performance. You are not worried about how much space it takes. You can use that. So it's a balance between what you are trying to achieve and what is the use case. So there is no definite answer, but since there is in RDBMS, we try to split it into different subject tables. I'm just following that. There is no definite answer to it.
Right, sir, I got it. Given this particular scenario, I would have only gone with denormalized data. But yes, if there are more options, if there is some other separate entity altogether, we can definitely go with it. But I
Sir
don't
is
see
talking, I
the
think,
services being a different.
sir is talking in the general way, like if we have the data, how to split. If you have like a short data, definitely we can go with the one table or two table. That's it.
See, the use case that I have brought in, eventually when you're going to do high level analysis, so this entire thing, right? The master file, I'll just let me just share. So where I'm taking this tool, I'll show you the master file. Where is the master file? Let me go. Okay, just give me a moment. Just give me a moment. Okay. Okay, so let me just quickly share my screen again. Just found out that. Okay, so this file I've not shared with you right now. Okay, with the files, other files, there is a zip file that will be shared with you. It's already uploaded in LMS, but it's not released for you. So in that set, this file is not there. Now I'll show you what is there in this file. Okay. See, it has all the columns, all the necessary columns as a single table, which makes, which is like supporting to what you are saying. Yes, this is what we do for analysis purpose, so that the performance is better. But when it comes to RDBMS, where you have transactions and all going, you prefer to have tables in for each subject. So to summarize it, what both of you were saying is correct. It depends upon what we are trying to achieve. In case of analysis, you might, if the data is not that huge, it's not taking a space, or your space issue is not is a problem. It's not a problem. You can denormalize it. On the other hand, if you feel that there is updations or things that might happen, we go with the normalization. Now, in the example that we are showing, since it's one-to-one relationship and since it's not huge data, you can go for denormalized as well as normalized. But I'm using the normalized way so that you know this is the way it has to happen. And if there are certain conditions that matches, then I can go with denormalized. That's it. Both are correct. Okay. I hope this sorts to a certain level. See, if I just make it as a single table, I can't show an ER diagram, right? There is no other entity, and I can't show. I'm trying to showcase how you can draw a diagram and then how you build a table. So if the entire thing I keep it as a single table, I can't show it. I know this case fits perfectly for that, but again, that's one reason. Okay, so back to where we were. So all these things are kind of the services. Okay, so let me just keep it separately as customer services. Let me call this as cost services. Okay. And then you have the last one which tells me the contract, payment method, churn, etc. Let me just this again separate, and this one also.
We are not able to see.
Sorry, I didn't hear that. Can you come again? There is a sorry.
Screen is not visible, sir.
See your screen.
Oh,
Yeah.
okay, sir. Okay. So this one becomes my customer. How should I put it? Maybe customer. This is something, some name, and this becomes my customer. So now you have created all these tables, but this has to be connected some way or the other, right? How can you connect it? You use the customer ID. That is the unique identifying thing here, right? You bring it as a foreign key to customer location. Okay, and you say that this customer ID is what is a primary key for this one, as well as this key acts as the foreign key. Okay, this references to the same thing can be done. Okay, see, this is a very simple example. When you have the assignments, I'll give a case where this is not that straightforward. You have to think and do it. I'll give that in such a way that you think and you have to split it. I'll come up with such a case. This is a simple one. Okay, just for the purpose of explaining. Okay, so what we did is we splitted it into multiple tables: customer, location, services, charges, churn, etc. And then to connect them, what we did is we took the customer ID, which is the unique ID, kept it to each of these tables. This acts as the primary key for those tables as well as the foreign key. Okay. Now, this is your initial thought process. It may be changed it may change depending on what data you might get after you draw the ER diagram. This is what you think. See, no one, it's a continuous process. You analyze it, you think that this is it, you draw it, you start inserting the data, then you figure out that okay, there is a problem with the data. You come back, you change it, and eventually you reach the perfect ER model and okay. So this is how it would be done. Now let's create an ER diagram for it. Okay, so we'll go to that DB docs. Let me just share again. Okay, now what is our table? The table is customer. Let me give it as customer. It is our column customer ID. Now the problem with this particular tool is that you will have to type in everything. Okay, first ID, which is an int, it is the primary key. It's not an incremental one. It can be int or it can be anything. So let's put it as varchar. Now next thing is the next column. Next column is gender, which is again text. Okay, then you have partner, which is text. Then you have senior citizen partner and senior citizen, again a text, and then it is again a text. So This is how your table looks. Now you can see that cust ID is bold because we have kept it as PK. If you remove that, that bold goes away. If you add it, comes it as a PK. So we have designed the first table. Now let's see for the second table, customer location. I have already written it down. So what I'll do is I'll just copy paste it. Okay. I've just copy pasted all of that. The problem with this kind of ER diagram is you'll have to type it out. That's the only way. Whereas when it comes to MySQL and all, what it does is after you have built the table, it does a reverse engineering and it helps you to build the ER diagram, which we will see in the coming sessions. Okay, I'll show you that as well. So we are concentrating more on SQLite. I'll show you how we can connect to MySQL, how you can do that reverse engineering there. I'll show you that as well. Now, all this is done, we need to show how they are related, right? How they are related. Relationships can be shown by customer ID, drag that and add it like this. Okay. Now when you add, you can see one and star. What does it mean is it has one-to-many relationship, but that is not true. Why? Because a customer ID can come only once in your customer churn. Either he has churned or he has not churned. So it is not one to many, it has to be one to one. How will you edit that? Scroll down and you will see something that has there. Reference customer ID, and you see this less than sign, right? Less than customer churn. This less than means one to many. If it was many to one, it would have been greater than. If it is one to one, it's a hyphen. Now if you come here, you will see one to one. Now again, the same thing goes for customer service, same thing goes for customer account, the same thing goes for customer location. Let me arrange it properly. Okay, now wherever you have seen, it's all one to one. And again, this adds to the point that was earlier told by, I think it was Chris, that why do I have to split it? If it's a one-to-one relationship, yes, you can keep it as a single table also. Okay, but just to showcase that this is how it is usually done, where in cases where you have many to one relationship, you will have to split it like this. I'm just splitting it. And this is the diagram that will come out of it. You can export it, keep it as a PDF, login, and then you can export it to as a PDF or as an image. Okay, this is one way of creating it. Now, after you have done this, what is the next step that you are going to do? You will write the DDLs to create this table, correct? You know, now you know that they have so many data points. I've logically split it into different relations. I've also defined what the relations would be, how the foreign key and primary key would exist. All those things I've defined. Now, I want to implement it in a DB. That is where you will start writing your DDLs, DMLs, and you implement the data, you insert the data, etc. All good?
Yeah.
Okay. Which takes us to the next simple topic, which is nothing but introduction to RDBMS. It doesn't have so many slides, no worries, it will finish it in maybe 10 minutes. Okay, because you know it's just the basic things that we are learning, and so don't worry thinking that it's already 4:40 and he's starting with a new topic, it will get over in 5 minutes. Okay, nothing. This is just how the relational database came up into the picture over the years. Just for information, initially it was from IBM. You had DBMS that was then created, and from there the ER model, etc., came into picture. Then you had the IBM DB2 SQL came into picture, which is a structured query language. From there were so many developments that happened by MySQL, which is open source PostgreSQL. Now you have all these DBs in your cloud, AWS, RDS, DB2 on cloud, etc. So everyone is moving to cloud. Just for information. Moving on. What is relational database? Database is nothing but a repository of data. Repository is where you store the data. You have data there. It provides the functionality for adding, modifying, querying the data. Different kinds of database stores different data in different forms. For example, you have columnar databases, you have row databases, etc. Next is a relational database. Data that is stored in tabular form is a relational database. RDBMS is a set of tools. So relational database is nothing but a physical thing where you store the data. What manages it? The software that helps you to insert data, modify data, that is what is called as RDBMS. It's a software tool that controls the data, helps you to access the data, helps you to organize the data, helps for the storage, etc. That is what RDBMS is. For example, you might have worked on Oracle DB, you might have worked on MySQL, etc. Right? So the front end where you type the query, the MySQL workbench that you see, the DB browser for SQLite that you have installed, all those are called as the RDBMS. It's a software or a tool that helps you to manage your data. Behind the scene, there is a repository where the data is actually stored, and that repository is called as the database. Okay, be very clear about this. RDBMS is nothing but a software. Don't think that MySQL Workbench is a database. MySQL Workbench is a RDBMS. It's a database management system. Okay, whereas your MySQL server or the MySQL data is where you store the actual database. Okay. Now, there are different types of relational database: the commercial relational database, open source relational database, and the cloud database. Here we would be concentrating more on the open source relational database, and especially SQLite and a bit of MySQL. What is SQL? I'm running through this because you all know what it is. It's just a brush up of what it is. SQL stands for Structured Query Language, language used for relational database. There are different types of SQL statements. One is the DDL. DDL stands for Data Definition Language Statements. It is used to define, change, or drop data. The different types of DDL statements are create, which is used to create a table; alter, which is used to make changes to the table, alter table; truncate, which is used to delete, the rows of the table; drop, which is used to drop the table as a whole, delete the table as a whole. Then you have the DML, which is data manipulation language statement, which is basically used for reading and modifying the data; insert, to insert the record; select, to select and read the data; to update, it helps you to edit the rows in the table; and delete removes a set of rows or all the rows from the table. Okay, DDL, DML. DDL create, alter, truncate, drop. Anything that happens at a table level, it's DDL. Anything that happens at a record level, it's DML. There are a set of inbuilt functions that is there in your SQL, like count, which basically gives the count of records; distinct gives you the distinct values that are there in the records; limit again specifies to certain databases only. In certain databases, it is top rather than limit. Limit 5 becomes top 5, etc. So it depends on the database actually. Where condition, trying to filter the data, you use where condition. Like helps you to do a regex. Between and logical and operator, logical on or in, to sort the data order by ascending and descending. If you want to find a certain aggregate function for a certain group, you use the group by. If you want to run a filter on top of a aggregated data, you use having. Any of this function that is not familiar to you? Anyone? Anyone? Any functions that is listed down here is not familiar to you? So that I can explain what it is. These are the most common ones that we use, and that is why I have not given an explanation of what it is. You know it, but I've just told it. Anyone, any issue with any of these functions? No. Next one are the other set of built-in functions, which is sum, min, max, average, length, round, date time, timestamp, time, date, lowercase, uppercase, etc. In different data, different RDBMS, different DBMS, you have different ways. In certain case, it's upper. In certain case, it's U case. So depending upon what DBMS that you're using or what DB that you are using, you will have to find out the appropriate function. You are not expected to by heart this, but it's good that you remember the most common ones. Okay. Again, the same question. Anyone, any doubts with any of the functions that are shown in the slide? What it does, what it means? Any doubts?
What was the explanation for the the previous slide?
So, for example, let's say that you have a column employee name, okay, and you want to find out all those people. The employee name has how would I give an example? Let me think about another example.
Can I say?
If you want to check for a pattern in a particular column, you use the like expression. Like, for example, you want to check.
Sir was giving an example of organization IBM India. So if IBM is in multiple countries, India, US, and you want to get the data for all the IBM operating in different countries, then you will say where the organization name like IBM percentage, and then it will get all the organization across the globe. Or like if employee data, if you go like Ram Arora, Ram Sharma, you want to get the all employees which is starting with the Ram, then you will say employee name is starting with Ram percentage.
So is it for string, Nidhi, primarily?
Yeah.
Yes, primarily for string, correct.
Okay.
For example, if you have something like this and you want to check for IBM UK and you want to check for all those records corresponding to India, your condition would look like where this column name, let me put it as BU. Sorry.
The screen is not showing.
Where BU like.
The screen sharing is not there, sir.
Oh, sorry. You probably are going to complain against me, right? This guy doesn't share screen, keeps on talking, lot of background noise.
No, not
okay,
really.
where do you like
talked with the guest,
percentage? So how it happens is, let's say that you have IBM India, IBM Business India, IBM UK, etc., and you want to find out all those records which corresponds to Indian business unit. If you search for where BU equal to India IBM, this won't come up. Correct? So what you do is you put a condition where BU like percentage India percentage. This will give you all those records which has India in it. So all those business units that are corresponding to India will come. That is the use of like.
Can there be more than one string things like with multiple companies, IBM and India, if I want to do?
IBM and India, yes, please. You can have an OR condition, which would look like this. Where do you like India or do you like percentage IBM percentage? So whatever that you are seeing in your inbuilt operators for SQL, it's a combination that we are going to use in the SQL statements. It's a combination. Okay. So where, like, and, or, etc. You use a combination of all these operators to achieve to pull the data that you want to get out of it. We will do the exercises and then it will be more clear. Okay. Any doubts with this?
Yeah, that's clear, sir.
Can you explain the having as well?
Having, having is, let's say that, let me again go back to Excel, but before that I'll share, I remember it now, Excel, okay? Now, let's say that you have country, okay? Then you have state, then you have sales, okay? India, state, Karnataka, sales is 14, India, then you have Kerala, the sales is 15, India, you have Goa, the sales is 20, India, Maharashtra, the sales is 14 again. Then you have US, the state is Arizona, the sales is 17, US, another state, New York. Sorry, I'm just coming up with examples. Might not be right. Then you have US. Another one is, I don't know if Seattle is a state or not, but it's okay. Seattle, it's like 18. Then you have UK, which has Birmingham, which sales is 70. Then you have UK again. Another one, Newcastle, where you have 17, etc. Okay. Now, what does group by do? It groups. Let's say that you want to find out how much sales has happened in each country. What is the thing that you have to do? You have to group the records based on the country and sum your sales. Correct? That is what group by does for you. Now, let's say that for India, when you did a group by, what is the value that is going to come up? Country, sales, 14, 15, 20, 14. That makes it 35, 49, and 63. Then you have US. What is the sum that is going to come up? 17, 16, and 18. That is kind of 17, 16, 17 into 3. That is 30, 51. Okay. Now you have UK. There are two, which is 17, 17, 34. Now, this is what you are going to get as the result of group by and summing of the sales. Let's say that on this result, you want to filter only those records which have sales greater than 60 or sales greater than 50. It should show only India and US, right? Correct? For that, you will use the having. If you have a group by function and if you have aggregated using a group by, and if you want to apply a filter on top of that, that is where you use the having. For conditions where you need to directly filter, you use where condition. Making sense? Query would look something like this. Select country, comma, what is that you need to get? Sum of sales, correct? Sum of sales from this particular table. Let's call this as sale table, okay? Sale table. Now, you did this group by, what is the group by? Group by country. This much clear. What you have done here is, you are saying that, hey, group these records as a country on the basis of country. Give me the sum of the sales. Now, what is the result of this SQL? This. But you also have a condition that the sum of the sales should be greater than 50. For that, what you do is, you write the condition having sum of sales greater than 50. This is how you use having. So whenever you have an aggregate function running on top of a data set that is grouped by, if you want to do a filtering above and top of that using this aggregate column, then you use the having. In cases where you want to do a filtering on the basis of column names, you use select star from tail underscore t, where state is equal to k. So if you do not have an aggregate function to be used for a filter, you use where condition. If you want to filter on top of an aggregate function running on a data set, you use have. Clear? Is it okay? Yes, no.
Yes.
Okay. Cool. Yes. Now share. Media. Now sets and joins. Okay. This is basic our mathematics coming into picture. Union. If you have two tables and you want to get table A rows followed by table B's rows as a single result, you use union. Now, what is the one thing that you have to remember when you do a union? Both the tables should have the same number of columns and it should have the same column names and same, at least the same types. Okay, same number of columns and same data. Clear? So, union, you have table A. Let's say that your table A has 10 records. Another table B, has 30 records. Table A has 10 records. Table B has 30 records. If you want to see this 10 plus 30, 40 records together, you do A union B. Okay. Now, there are two caveats to it, or two constraints to it. The first one is table A and B should be similar in structure. And if there are records that are both in table A and table B, only one of them comes in. So for example, table A has 10 records, table B has 30 records, and this table B, out of these 30 records, 10 records are same as that is what is there in table A. When you do a table A union table B, you are not going to get 40 records, but you are going to get 30 records. Union automatically omits the duplicate records. If you want to see the duplicate records as well, then you use union all. Okay, so union, two things, table A and table B, or n number of tables, you can do a union. All the tables should have similar structure. If there are duplicate records coming in, union will omit it. If you want to see the duplicate records as well, you use union all. Intercept, table A intercept table B would give you all those records that are there both in table and table B. Table A except table B would give you all those records that are there only in table A and not there in table B. Joins, you have different types of joins. Table A join table B. Inner join gives you the common records. Left join gives you all the records from the table 1. If there is a corresponding match in table 2, it gets populated, else it gets populated as null. Right join, all the records from table 2 would come up. If there is a corresponding join in table 1, that record gets populated with the value from table 1, else it will get populated as null. Full outer join, entire records from table A and table B comes up. If there is a match, the records will come up accordingly. If there is no match, nulls will be populated accordingly. Any doubts on this? Anyone who doesn't know the idea of joins, should I come up with an example to explain full outer join, inner join, drive, any kind of explanation required here? Anyone?
Yeah, can you just give a very small example?
Of which one?
It's like
Join? Sorry, can you come again? For which one is a join set or everything?
Join.
Or is there a specific thing that it's join? Okay, great. Let me just share the Excel again. Microsoft Teams, share. Okay, let me just start a new sheet. Okay, so let's say that you have cost ID 1, 2, 3. Okay, yeah, cost.
Hello.
Hello, yes.
Yeah, can I do
yes,
it
please.
SQL tools instead of Excel sheet? Then
yes, we will be going to that as a hands-on exercise. We'll go there.
okay,
I'm trying to explain the concept only. We will have practicals, no worry. See, it's all practicals, no worry. Don't worry. Okay. There's no point in teaching some and then going away. We'll have practicals. It's just to make the concept clear that what happens behind the scene. I'm using Excel. That's all. Okay. KL. Let's say that you have two tables like this. Okay. Now, let's say that I'm going to join this table A with table B. Okay, let me call this as table cost and let me call this as table take. Okay, now let's say that you are joining cost, inner join, okay, state, and what is the column that you're going to join? State code. It's joined on the basis of state code. If it's an inner join, what is going to happen is it tries to check whether there is 11 here. Okay, and it brings up all of that. So what are the records that are going to come is 1 Rahul, 11, 1, 11, KA. I have just given the entire, it's a select star. Okay, again 1 Rahul, 2, so where is stated? 1 Rahul, 11, 2, 11, KA. Then you will have 2 Rohit, it's coming to 11, correct? 2 Rohit, 21, 3, 21 KL. Now, Raju won't come up. Why? Because there is no 31 here. Making sense? This is the column to which you are trying to join. This one. Okay? What it checks is, it takes 11, checks for records which has 11, joins them. So here there are 2 records which has a value 11. Okay, and that is why you see 2 records coming up here. Then it takes the next record 21. How many records are there? There is only 1 record. So you see that 1 record. Now you come up with 31. Is there any record here? No, nothing will come up. This is what happens in your inner join. If there is a matching thing, it brings it up. If there is no matching, it doesn't come up at all. That is what inner join is. Now, left join is checks whether there is a match. If there is a match, it gets populated. If there is no match, the left hand side has extra record, it gets populated as null. Here you have 3 Raju, 31. There is nothing to populate here, right? So it gets populated as null, null, and null. This is what left join does. If all the records that is there in your left table would be populated. If there is a corresponding match, the corresponding matching records would be populated. If there is no match, null will be populated. Okay. Now, let me add one more here. So 35 EA. Okay. Now here, if you see, even now the left join remains as it is. Why? Because only those records that are there in the left table will be populated. It doesn't matter if you have more records in right table. Making sense? You take the first record, check if there is a match, populate them. Second record, if there is a match, populate them. Third record, if there is a match, populate them, else populate null. If the number of records in your left hand side ended, done. That's it. Now, on the other hand, if you do a right join, what happens is it starts from the right hand side. So first thing that happens is it takes the state code 11. It matches with Rahul. It again goes with the state code 11. It matches with Rahul. Okay, so 2 records. Then it takes 21. It matches with Rohit. Then what it takes is 35. Does it match with anyone? No. So what will happen? 35, since it's a right join, the right table's record would get populated, which is 4, 35, GA. But since there are no corresponding records here, null gets populated. Clear up till this much? Right join, left join, and inner join. The last one is the full join, full outer join. Okay. See, in certain RDBM and DBMS, you have to write right outer join, left outer join, etc. In certain RDBMS, right join is enough. Okay. So depending upon which DB that you are using, change it accordingly. In certain places, it's okay. Most of them are trying to unify it, which is right join, left join, etc. But in certain places, you might have to add an outer. The meaning is same. The operation is same. Okay. Now, what does full join do? Full join is very simple. Both scenarios coming into picture. The left join plus right join is what full join is. This will how your full join looks. Right join plus left join. That is what full outer join. All good?
Yeah, thank you.
So, sir, when you did the right join and when the records, the first 3 attributes are null, right? So, will the system throw an error, constraint error or something?
This is a select statement. This is a select statement. You are not building a table. The null things would come, the null constraints all comes when you're creating a table. You're writing a select statement to see the result, right? It's a select statement. If you remember, we had that slide where I was asking, right, what all constraint violations would happen for insert, delete, etc. And then at the bottom you had select, which had no constraint violation. Because it's a select statement, there will be no constraint violation. Hence, there will not be any error here.
Okay, so between select and the creation of a table, are there any steps in between?
Are there any steps? No. You create the tables, then you select the table using your select statement. You can join different tables and then you can select all those things. We will come to that. Okay, we'll come to that.
Sure.
So sharing, where is my PPT? Let me quickly in. Yes. Okay, you only know it's join. Then we'll do the hands on. Okay. So what I'm going to do is I'll pass you the SQL queries, okay, to create the table. So this is the ER diagram which we will be following to create the table for this. Now we all know this is the ER diagram that we will be following. We all know that there are so many tables, etc. I'll give you the DDLs. DDLs is basically creating this table, create table, table name, the column names, the data type, the size of it, what is the foreign key, what is the primary key, etc. Will give you the statements. You can copy paste it and run it. Okay. Before that, everyone, I hope everyone has installed DB browser for SQLite. Anyone who has not installed DB browser for SQLite? Anyone? Everyone has installed. Okay. So can you just get started with it? Can you click on the DB browser for SQLite from your program?
It is crashing actually. It is that server is not running. It is stopped. There is some issue with my operating system. It seems.
Which one? MySQL?
Yeah, yeah. MySQL work.
Workbench. We will. I mean, maybe after the class, if you can stay back, we'll try to debug it. But we'll work on SQLite right now. Okay, DB browser for SQLite. Yes.
Sir, I only have console access.
For
MySQL.
Your laptop. No,
No.
that's okay. Forget about MySQL. MySQL is just an add-on. Our primary thing is not MySQL. We'll be working on SQLite. There's a reason for that because Python comes in with SQLite inbuilt. Okay,
right.
And hence to integrate Python to SQLite, it's very easy. And why we are looking for Python SQLite is, see, there is a last module where we are trying to connect this entire thing, and we are trying to say that, hey, this structured data can be given for data science projects, for data scientists to write their Python code and connect to SQLite, write their SQLs and bring the data. Okay, so there is a connection module that we do, which is SQL for data science, and in that place, SQLite is what we are using, and hence we are sticking on to SQLite. But since MySQL is also one among the popular things, I thought I'll just give a brief introduction about MySQL Workbench, how you can connect Python from Python to MySQL Workbench, etc. So I'll take a brief session, but our major working tool would be SQLite.
Okay. Got it, sir. Thank you.
Yeah. So everyone has DB browser for SQLite? Anyone who hasn't installed it? Go to your all programs. Yes, please.
Sir, we have not installed it, sir. Give us.
Sir, I'm installing it now.
Yeah.
Even I don't have.
Guru, it is very small file, very small. I believe in few MBs only, so we can install it within seconds.
So what are we supposed to do now?
Yeah, Krishna, I'm doing the same.
Sorry, someone had asked a question. What are we supposed to?
Yeah, so what are we supposed to do now? I'm sorry, I quite didn't catch that. Are we supposed to install something?
Yes, have you installed? So as prerequisite, we had requested to install two things: MySQL Workbench, MySQL Server, etc., and then something called as DB Browser for SQLite. And the download links and the installation documents were shared. Did you get a chance to install those?
Oh, apologies. No, I don't think so. I've done that.
Yes.
So does it take quite a time?
Can you go to your LMS? There are two documents, installation documents, three documents. One for installing MySQL in Windows, one for installing MySQL in Mac, and then you have an installation document for SQLite. Can you just open the SQLite one, go to that particular web link and download it and install it?
Okay.
Yeah, I'm done with the installation.
Great. So select, click on, so for all those who have installed, go to your programs, all programs, and search for DB browser for SQLite. Click on that and the application launches. All programs, Windows, click on Windows, type in DB browser. Yes, please.
So is it possible to create servers also using this using these SQLite?
Servers as in the sense, can you explain a bit more?
SQL server. You have to create a server, right? SQL server.
See, so there is a server running behind your SQLite, be it MySQL Workbench or SQLite. There is a server that is getting installed in your laptop. Okay. Now for SQLite, it's just a plain file, and that file acts as the server. For MySQL, you have a server. So depending upon which one you are using, okay, I'll give you the answer like this. For SQLite, you can't, and that is why the size of the file is so less. It doesn't have a server or anything. What it does is it stores your data into a file, and then it uses that file. Whenever you run a query, it brings it as rows and columns, tables, etc. But for MySQL, you have a MySQL server. While you install, MySQL server gets installed. Okay.
Right, sir.
SQLite is usually for educational purpose. I have not seen anyone using SQLite on a commercial basis. It's usually for educational purposes, whereas MySQL and all is for commercial purposes. And that is why SQLite doesn't have this server or anything. Whereas MySQL Workbench, MySQL has servers, command line interface, etc. Everything is there.
Yeah, when I done the installation, right, I could install the workbench only, but it has, by default it has not installed the server. So do I need to reinstall again?
That is for MySQL, right? We will come to that later. Okay, MySQL, that is an optional thing. When I get if we get time, the next week after we finish of the topics, we will do that.
Could you please just tell that what application we have to install and what will be the sequence? What should be the sequence of them? Right.
There is no sequence. Go to the LMS. You can see 3 documents there. Okay. Installation document 1 for MySQL installing on Mac. Then you will have installing for Windows. Forget about those
I
2
don't
documents for the
see that documents in LMS. I don't know in which in the course tab I can see that documents, or where.
Someone has to help me from Reva team right now. Rujal or Ajin is not there, so let me just check.
BS10, right? No, the instruction for the installation, is it?
Correct.
Yeah, just a minute.
I was informed by I think I was informed by Ajin that it was uploaded, I guess.
Yeah, it's uploaded for AI, right? AI patch, but
yes, sir, it's uploaded for BA10 too.
Is it?
Yeah, it's in class material.
Yes. To install it. Yes, it is there on BA10, but for some reason when I unzip it.
File, yeah. The zip is not. Let me just download that thing. Let me try opening it. Yeah, it is there. Maybe I can just quickly. Yeah. Just a minute.
Sir, in that case, can we have this session next week then? Because I think everybody comes with the installation. We can have this hands-on.
Yes, we can do that next week, but there will be a problem there, which is next week is the last session, and I'll have to finish off the topic, so it might get stretched a bit, depending upon how we finish it. If you're totally fine that we can wind up the session right now.
Yeah. Otherwise, I don't think so, sir. Everybody we have installed, so that is where. So I think it will be good that everybody comes with the installation and then go with hands-on.
Sure. No issues. Okay, so feel free to message in the group if you have any doubts, or if you feel that you don't want to message in the group and get the answer. Feel free to message me in WhatsApp. I'm there in the group. Find the number and then message me if you have any queries. I will be more than happy to help you out. If you call me, it depends. If I am free, I may pick. If I am in a meeting, I might not pick. Similarly, if you message, uh, definitely I will respond back. If you call, I might not call you back because I don't know your number, so I might not call you. But if you message in WhatsApp, I'll definitely respond depending upon how free I am. But before the day ends, I'll respond to it. Okay. So any queries, any questions regarding installations or what we have learned up till now, feel free to ping me. I'll be more than happy to give whatever answers that time. Okay. All good. And again, before I wrap up the session, apologies for all those background noise. Sincere
No,
apologies.
no, you don't have to. You don't
Oh,
have
yeah,
to.
I think it was only,
It
for a
was
small
okay.
duration,
Yeah.
nothing to be worried. Sir.
Okay, so we'll meet next week, 10 o'clock. It kindly we'll go in a bit more quicker pace, but without missing any of the required details. Okay, we'll meet next week. And as I told, if you have any queries, feel free to ping me in WhatsApp. Okay. Thank you. We'll meet next week.
Thank you.
Bye. Bye all.
Thanks,
Have a
John.
nice weekend.
Thank you.